All right, folks, it's Bass Action back in action here. On this video, we're going to look at how to write equations of hyperbolas using both a graph or just some characteristics. It's going to be very similar to the previous video that we did for ellipses. So let's get some basic things set up here. When I look at this graph, I can see that it's opening horizontally. So I'm going to immediately note that for myself, because that's going to help me establish my initial form for my standard form. I know that I'm going to have a fraction minus a fraction. It's going to equal 1. I know that the numerators of each fraction need to be binomial squared. And then based on the direction of the opening, that's going to tell me whether it's an x or a y that goes in the first term. So because this one is opening horizontally, I'm going to make this an x and I'm going to make this a y. Now from there, we're going to come over and we're going to look at our graph. We can look at our center and see that our center is a negative 1, 3. And I can then put that into my equation. So x minus the negative 1 for the numerator will become x plus 1, y minus 3 in the second term. Then I'm going to look at the horizontal distance from the center to the box. Okay, so this horizontal distance is a 2. I'm going to square that, put it under the x's, which will make it a 4. My vertical distance is a 5. I'm going to square that and put it under the y, and that's going to give me a 25. So that's our entire equation. Now, this initial part, I got to emphasize this one more time, that determines whether or not it's an x or a y that goes in this first term. This needs to be established first. Just like on the ellipses, I gave you some extra practice here. So remember, we could fill in our center down here if that was all that we were asking for of this negative 1, 3. If we could find the c value, remember the equation is c squared equals a squared plus b squared. So we'll have a c squared of 29, adding together the 4 and the 25, which makes our actual c value a square root of 29. That's going to be the distance from the center to the foci. So you could practice getting each of these parts that we worked on in our previous lessons. Now the next one that I want to look at is I want to write an equation for a hyperbola just based on some characteristics. So we are going to have to create our own sketch. So I like to go ahead and identify right off the bat what part stays consistent for all the values that they gave me. And then from there, I can start to create my sketch. So all the y coordinates are going to be the same. I can see that all my x coordinates are positive. So I can set up this sketch here. And I don't want to use the highlighter one. So I'm going to set up this sketch. Just give me a xy axis here. So I'm going to grab the vertices first because those will be the closest together. And I'm going to have a 5 and a 15. So I'm just going to eyeball it just way over here. Remember, they don't have to be to scale. So I'm going to have my 5 and my 15, and I'm going to have a negative 2. I'm just trying to get them in the proper quadrants. So there's my 5 and my 15. I'm going to label those vertices. Then I'm also going to label put the foci on there. Those are going to be at 3 and 17. So I'm going to have a 3 and a 17. Those are also at a negative 2. So those are my foci. So from this, I can see that this is opening in the horizontal direction. So just like the one that we did up above. So just like we did up above, we can establish a couple things. We can set up the general form for our hyperbola. Fraction minus fraction equals 1. The numerators of each fraction are going to be squared. Because this is opening horizontally, I'm going to put the x first. If it had been opening vertically, I would have put the y. So I'm going to go ahead and put my y in my second term. When I look at this, thinking about the center, I at least know that my center has to be along this line right here, which means I do know the y coordinate of my center right now. So y minus a negative 2 is going to be a plus 2. I can find my center knowing that it has to be between the vertices. Okay, it has to be equidistant. You might be able to count it, visually see it. It's going to be a 10. If you want to work on it algebraically, you would do 5 plus 15 divided by 2 would give you the 10. So that now tells us the x-coordinate of our center. Then what I'm going to look at is the distance from my center to my foci is going to tell me the horizontal distance for my graph. So the distance from my center, I'll even give myself a little dot here, from the center to the vertices, I meant to say, to the foci will be my C value. The distance from my center to my vertices I can see as a 5. So that's my horizontal distance. I'm going to square it and put it under the x. I can see that the distance from the center to the foci is going to be 7, and that's going to be my C value. So now I'm going to remember that I've got C squared equals A squared plus B squared. C is the distance to the foci, so I'm going to fill in a 49. 5 is the distance to the vertices, so I'm going to put a 25 there, plus B squared. I subtract that 25, I'm going to get B squared equals 24, and that will then go under the y. Remember, it doesn't matter whether it's bigger or smaller for the hyperbola. And that is our equation from characteristics.